Server-managed recovery with RMAN. At this point in the training, we are quite familiar with the Recovery Manager tool, but only from a backup point of view. In the previous nugget, I taught you the basics of user-managed recovery, in which we used operating system commands to restore data files and various other components of our Oracle database. Here we're going to do many of the same things. We're going to go back to that distinction, for instance, between complete recovery and incomplete recovery. I think you're going to find, as I promised in the previous nugget, that using RMAN for these tasks is so much more straightforward than it is when we use user-managed techniques, for sure. A third and very particular exam objective we'll be covering in this nugget is the use of image copies for recovery. As we're going to learn, we already know that image copies are bit-for-bit duplications of your data files, and that also storing image files is a nice way to do fast recovery if you don't have the extra time involved in pulling backup pieces and reassembling objects from backup sets. Well, we're going to learn some pretty cool tricks in this nugget for not only running image copy backups, which we already know how to do, but also incrementally updating those image copies so that they're always fresh and can give us really fast restore and recovery times. Good stuff to learn in this nugget. Let's get started. The first scenario I want to cover is the worst case scenario, what Oracle in their literature calls disaster recovery. Now, sometimes these vocabulary words are a little bit different depending upon your context. For instance, remember when we talked about incremental and differential backups? I warned that if you were coming from another database platform, particularly Microsoft and SQL Server, you might get a little confused because Oracle's use of that terminology is different. Similarly, I myself sometimes will use the term DR, or disaster recovery, to cover the entire spectrum of backup and restore. But that's not the case with Oracle, and for your exam, of course, above all else, we have to keep in mind that we are fully Oracle-centric, and all Oracle cares about on their certification tests is that you understand terminology as they use it, alright? So to repeat, disaster recovery in an Oracle database context refers to the loss of everything. We're assuming that the database, all of its data files, your control file, your server parameter file, your redo log files, most or all of those are gone. And there's so many different scenarios that can explain that. We covered that at the beginning of this training course, as a matter of fact. The question is, in this nugget, what do we need to be able to recover from this worst case scenario, and what do we need to do? First, the recipe list, the ingredients list, I should say, for this recipe states that we need to have current data file backups, archived redo logs, and a backed up control file and server parameter file. Now, if you're running your Oracle 11g database according to best practices, you're already running in archive log mode, so you should have, should being the operative word, some saved backups of your redo log files, which we're assuming have gone up the flue in this disaster recovery scenario. I also taught you when we did RMAN configuration that it's remarkably easy to enable not only control file but server parameter file auto backup, such that every time you run an RMAN backup job, RMAN backs up these files. And as you're going to see in the demo we're going to do, as long as you have those auto backups, your bases are fully covered in terms of restoring those in a pinch. Finally, we'll want to make sure to use the flash recovery area, also called the fast recovery area, just so we don't necessarily have to worry about format clauses and specifying file paths. Especially, and some of you I think can relate to this, in an emergency situation you don't want to be futzing around with fancy syntax. You want to actually restore and recover the database as quickly and accurately as possible, and as I hope you believe along with me now, the FRA goes a long way to making it a no-brainer to pull stuff out of your recovery store. Alright, so that is our ingredients list. The recipe for doing a complete database restoration involves doing a shutdown abort. That would be step 0. If your instance is already just down offline, you may not have to do that, but sometimes Oracle will just stop responding and just be in a totally hosed state. In that case, you can issue a shutdown abort just to make sure that the instance is down and the database is closed, even by force. You'll next want to get the database into a no-mount state, at least get your instance instance, your memory structures and your processes up if that's possible. As long as your Oracle binaries haven't been damaged, you should be able to do that much. And in a no-mount state, you can restore the server parameter file and the control file. Like I said, I'm going to show you how that works in the upcoming demo. That's definitely where we need to start because, as you know, the server parameter file contains all of the initialization parameters for a given database, and the control file gives you the location of your data files, among other stuff. So once those are loaded, and we understand that they may not be current, they're only going to be as current as our most recent backup, we'll then mount the database and go ahead with a restoration and recovery of the database. Remember again, to cover our Oracle-specific terminology, restoration refers to placing known good data files in a production location. You can overwrite old files or you could restore to a new location. It depends upon what you're trying to accomplish. That's fine, but then you're not going to be able to open the database until you've recovered the data files, or in this case, you'll issue a recover database statement, which will synchronize the system change number in the control file as well as in your data file headers. Remember that the SCN refers to the clock cycle or the current state of the database on a transaction by transaction basis, and the way we're going to synchronize the SCNs is, of course, by restoring our archived redo log files. I hope now that you've taken as a general point in this training the crucial importance of those redo log files. You're not going to be able to restore and recover a database to anywhere near point of failure unless you have those redo log files, which again backs up one more step to the importance of running your database in archive log mode. Once recovery is complete and you have synchronization between the control file, and of course you might remember the good old friendly RMAN recovery catalog. We haven't talked about that in a while, but that resynchronization would be part of the recovery process. We can open the database, and when we open a database, it's going to be important to issue the reset logs statement along with open database. Now, what reset logs does, as I've mentioned a few times in the training thus far, is it creates a new incarnation of the database. It's going to reset your SCNs back down to 1. It's effectively like wiping the slate clean and starting the database in a pristine state. To draw a rough analogy, it's like reinstalling Windows on your system. When you finish the reinstall process, you have a pristine installation of Windows that is in effect the way Windows looked when you first bought your PC. So reset logs comes into play quite a bit, especially and particularly when we have to restore the control file, because of that crucial importance of synchronizing SCNs and just kind of making it easier for your database to keep track of those system change numbers henceforth. Now, how about the restoration of the server parameter file and the control file specifically? As we know, the server parameter file is a tiny little file, but without which the database is not going to function. It stores all of our parameters. Now, if you've covered my CBT Nuggets course on the DBA 1 exam, you know how to create an SP file from P file, create P file from SP file, do all that kind of stuff. That's fine. But in the event that you didn't do that, well, how are you going to recover? Well, I would hope, and we're going to assume for the purposes of this nugget that this is true, that you are running auto backups in your RMAN jobs. And if that's the case, you really don't have to worry about it, because you can simply start up in no mount state. You're not going to be able to mount the database without the SP file, and then you'll restore from auto backup. On the control file side, it's the same basic idea, just remember we have the extra step that we have to open the database with reset logs, and actually even before that, perform the recovery process on the database to synchronize SCNs. Question that may have come to your mind, well, what about the backup control file command that we have in SQL+? Let's say we weren't doing an RMAN auto backup. What about backing up the control file by hand manually from RMAN? Is it possible to restore there? And actually you can. In RMAN you can issue restore control file from. You can actually restore the control file to a new location with restore control file to. It's important to keep up on syntax here so we understand the different possibilities that are there for us. Finally, I will say another SQL Plus command, going back to the SP file, that's kind of cool. And I don't know how many Oracle DBAs know about this. There's a clause where you can run create SP file from memory or create P file from memory. Now that assumes that the instance is up and running and you have the server parameters loaded in memory, but that's just something else just to keep in your tool belt as a possibility if you need to take a quick snapshot of the current state of the server parameters, the Oracle parameters, from a memory image. Now then, complete recovery. In Oracle nomenclature, complete recovery is going to apply all redo contained in the archived and online logs to a backup. Now in this whiteboard, we're talking about complete database recovery. The idea is we've had a media damage, a media failure that has done damage to the control file and or one or more data files, and we want to bring the database right up as current as we possibly can. Now we have some flexibility with complete recovery, you'll remember. We can actually perform it at the database level as a whole, the table space level, which embraces multiple data files, or we can actually work on data files individually. Now the path that we're going to use to do complete recovery is going to depend upon whether the damaged files were critical and non-critical. And before you say, Tim, you've covered all this stuff, why are you repeating it? I do want to go a little bit deeper on this distinction between critical and non-critical, because as I watched and played back my previous nugget and was discussing this distinction, I'm afraid I might have given you not the clearest description, especially as regards critical files. Now, critical data files are data files that exist in the system and undo table spaces. I made a reference in the previous nugget that if a data file has active undo, that's a critical file. Well, the critical file I'm talking about is within the undo table space, not the user table space with a user data file. Those are officially considered to be non-critical. The database theoretically can still exist if your user data files are broken or offline. It's just you won't be able to query any of the objects contained on those data files. By contrast, the data files within system, for instance, are where your data dictionary lives, where all of your user accounts live. You're obviously not going to be able to use the database at all. It's not going to open unless you have those data files available. And the purpose of undo, we'll recall, is read consistency, the ability for one user to issue DML SQL against data and other users to come in and see consistent views of the previous or before image of those data blocks. Those get stored temporarily in undo. Because this issue of read consistency is so crucial in Oracle, Oracle considers undo table space to be critical. And if we are dealing with complete recovery of a critical data file loss, we're going to start the instance and put the database in mount mode. If the failure, by contrast, is a non-critical data file, remember the presumption is that we can have the database open and we can perform a hot restore, and the only object that would be inaccessible during that complete recovery period would be either the data file itself, the affected data file, or we can kind of use a broader brush technique and take an entire table space offline temporarily while we provide the restoration and recovery. Now then, my middle point here says that RMAN makes recovery easy, especially if we're using Flash Recovery Area and Archive Log. And I'm going to go further. We're going to spend time in Oracle Enterprise Manager, also called Database Control. Sometimes in the Oracle literature, you'll see references to Database Control. When you see that, they're referring to the web application that we call OEM, Oracle Enterprise Manager. And what I think is kind of cool about this is that in OEM, we have a full front end to RMAN backup and restore functionality. In fact, when we run through the restore and recovery wizard in OEM, the deliverable is an RMAN script that we can edit. We can actually copy and paste it right out of OEM to put in our own, for instance, .rman script file. You see? So I submit that use of Oracle Enterprise Manager for RMAN backup and recovery represents a convenience to us as Oracle DBAs, and also for our purposes as exam certification candidates, this is an excellent learning tool as a way to check your syntax and make sure that instead of just clicking buttons through a GUI interface, you understand under the hood what's actually happening with the RMAN executable. We'll recall that incomplete recovery in Oracle terminology is called point-in-time restore or point-in-time recovery. And here we're intentionally going to recover the database and the redo log stream only to a particular PIT or point in time. That's not necessarily where the actual failure occurred. With complete, we're assuming we want to bring the database right up to the last committed transaction. With incomplete, we're intentionally stopping before that. The two reasons, by way of review, that we would do this would be A, if something happened to our current redo log files and we just couldn't go past a certain point, that would be a dead end for us. Number two, we might have had an administrative or user error in which we decide, all right, we've had some user mess ups here at 3 p.m. Let's do a point-in-time restore to 2:59 p.m. and call it a day. To do incomplete recovery, we have to put the database in mount mode, and we're going to use a special clause, recover until. And you'll remember from the previous nugget on user-managed recovery that we can stop incomplete recovery by specifying a specific SCN, or more commonly, we can use a time date stamp. The third way is to selectively roll forward our redo stream, one file at a time, until we choose the cancel command, at which recovery stops. When we finish incomplete recovery, yet again, we're going to have a discrepancy between the SCN in the control file and the SCN recorded in one or more data files. So when we open the database up for use, we're going to have to again issue that reset logs clause. The final subject in this nugget before we head into our demo is the notion of using image copies in recovery. The idea here again is that image copies are bit-for-bit copies of your data files. So if we have a 10 gig user's data file in our production database and we take an image copy backup, we're going to have a 10 gigabyte duplicate of that file. Now, if you can spare the space for doing that and you can spare the time it takes to do that, well, that's cool. That's fine. Because the plus side of that is you can literally just swap back the file in terms of doing a restore. Now, you may be thinking to yourself, well, what if I do an image copy every night and have a failure at 1 p.m. the next afternoon? I'm not going to necessarily want to just slap that file back because I may not have any redo, or how would I handle the issue of redo? The good news there is that you can actually run incremental backups and add those deltas or those changed blocks to your image file backup. The benefit here is that you can double speed your recovery. Not only will you not have to have RMAN dip into a backup set and pull out backup pieces and reassemble those, RMAN instead can just grab the file. The second benefit, speed-wise, is that incremental backups that apply changes to that file give you a much, much more up-to-date image copy file than you would otherwise. So finally, this little run block we see down at the bottom shows an example of what you might want to do to run incremental backups every night on an image file. Let's take it line by line. In the first line, we run backup incremental level 1 for recover of copy. We're going to do this in this example on the entire database, but you could do it at the data file level if you want to as well, with tag. Now, it's important to use tags here when you're using incremental image copies, just so it's easier for you and RMAN to know what's going on file-wise. Now, you might be asking yourself, why are we running an incremental level 1 here? We haven't yet done an incremental level 0. The beauty of this is, the first time you run this run script, RMAN will look for a level 0 of the database, and if it doesn't find one, it will create one for you. And then on subsequent runs of this script, there will be a baseline level 0 there, and then subsequent level 1s will just apply the changes to that tagged backup file, inc_image copy in my example. Now, the second line of this, recover copy of database with tag, is the magic command that applies the incremental. So the first night you do this, you're going to actually have a level 0, aren't you? The second time you do it, you're going to have a level 1 that contains changed blocks from the level 0. But the recover is cool because it's going to synchronize or blend in those deltas into the image copy backup. It's really quite an elegant little script when you think about it. And then at the end of the day, or at the end of the process, if you do need to swap in that file, you can literally switch the file in. You don't even have to change its location. In fact, in the demo, I'll show you that when we're doing image copy recovery, we can simply tell Oracle, look, hey, where you used to look for point A or file path A to find this data file, you can now find it in location B, and then issue a recovery to make sure that SCNs line up and any additional redo gets applied, and you're in business. Very elegant indeed. Alrighty then, we're going to begin this demo in Oracle Enterprise Manager, also known as Database Control. I just want to verify that this server is in fact configured for archive log mode and that we're using the flash recovery area. In this nugget, we're focusing on RMAN recovery, of course, and the absolute best way to use RMAN for recovery is to ensure both of those are true. So let us now, from the availability page in Database Control, come down to recovery settings, and we'll just verify first of all that under media recovery we are running in archive log mode, and I do have a custom path here. I'm not using the default diagnostic dest location because I don't want my archived redo logs in my Oracle-based directory. It's a very surprising bad default in my opinion. It should never be that way. Same with the default location for the flash recovery area. I have gone in and changed that path to my E drive, put the FRA folder on a separate disk. I've also bumped up the size of the flash recovery area to accommodate the backups we're going to be doing. Speaking of backups, we're going to start off in RMAN, but then I'd like to take you into Database Control so you can get familiar with doing backups through the Database Control front end of RMAN. And remember what I said during the whiteboard portion of this nugget, where Database Control will ultimately deliver to us the RMAN statements that it will execute. So we'll have the best of both worlds really as students. Now I'm going to fire up an administrative command prompt here, and I want to just check my RMAN configuration too. So let's just jump into RMAN directly. Now before I go any further, I want to point this out to you. When you log into RMAN and hit your target database, you'll get an echo statement here connected to the target database, and it'll give you the Oracle SID and also a numeric string called a DBID. Now you're definitely going to want to make a note of that DBID just as best practice. Do it as early in your Oracle DBA work as possible just so you have it, because in some recovery scenarios you're required to provide the DBID. For instance, if you lose your server parameter file, you're going to need to tell Oracle in another way what database you're talking about. So this is a very important identifier. There are a couple different ways to reveal the DBID. Another is through SQL+, you can select DBID from $database, but this is by far the most convenient method. And as you see, I've popped that into Notepad and I've saved this file as dbid.txt. That way I'll always have the appropriate DBID on hand. Now that we're in RMAN, I'll run a show all just to take a look at our defaults. And I've made some changes here. You see that I've bumped up my parallelism to 2. I've changed my default disk backup type to compressed backup set instead of uncompressed. I've turned on control file auto backup, and I'm leaving the %F format option. This is important, and actually this is another way that you can get the DBID if you're stuck. If you have a hosed SP file, you can't start your instance, so you can't get to $database. You can't connect to a target database in RMAN. What are you going to do? Well, you can dive into your auto backup file, and the file name itself will include or lead off with the DBID as long as you're using that %F. So that's a good option to have configured in RMAN. And finally, I have the backup optimization feature on just to save myself some disk space in terms of not redundantly backing up the same blocks if they haven't been changed. Alright, so the first scenario we're going to look at is recovering from the loss of control files using RMAN. You'll remember we did this using user-managed techniques in the previous nugget. I think you're going to like it this way a lot better. Now let me exit out of RMAN, clear the screen, and we'll come into SQL+. I'm going to check the location of my control file by running show parameter control, and we'll see this is just, again, stock defaults. I have one in my Aura Data subfolder, the other in the previous location of the flash recovery area. Okay, we'll need that in just a moment. Before we do, though, I want to make some baseline backups, and certainly we want to have a auto backup of our control file and our SP file. While we're here, actually, let me just run a show parameter SP file just so we can make a note of its location. It looks like it's under the Oracle Home Database SP file orcl.aura. Good, so we're going to need that a little bit later. But let us exit SQL+, come back into RMAN, and let's run a couple baseline backups. How about we do a backup database plus archive log to make sure we're picking up those. And I'm going to add a tag here. We'll call this complete backup. Of course, it would help if I knew how to spell, so let me up arrow and arrow over and fix datbase and make that database instead. And it's taken. I have parallelism set to 2, so you see that we've allocated, or should I say RMAN has automatically allocated 2 channels for the job, and we're building out the results of that set. And we should see, and we do, that those pieces are being placed in my new flash recovery path, EFRA, and you see that my tag is embedded in those file names. Looking good. Looking good. Okay, the job is completed. Final thing we'll see after the threads back up the data files, because I have auto backup specified, we do have auto backup of control file and SP file indicated. After that ran, I went ahead and did a list backup just to verify the status of these files. You see that the compression flag is turned on. The tag is very easily accessible to us. Again, that's a very good best practice for you to keep in mind. I want you to see that each data file in this backup set, or in these backup sets I should say, have a checkpoint SCN value. So there are many ways that we can delve in and work with SCNs. You don't have to be within RMAN. As a matter of fact, there's an Oracle utility called LogMiner that's used specifically to mine your redo logs to look for SCN values. It makes it a lot easier when you're doing SCN-based incomplete recovery. Now at the end of this backup run, you see, sure enough, SP file and control file references, and for the control file it gives us the highest SCN in that control file as well as a time and date stamp, which is kind of cool. It's useful info to have. Now as far as restoring that control file from a backup, we're going to assume that the instance is down. I'm going to issue a shutdown immediate, and I'm not going to actually nuke the control files this time around, because you remember what happened the last time in the last nugget. It's basically the same idea. If one or all of your control files are missing, you're not going to be able to mount the database. It's as simple as that. I'm actually going to reconnect to RMAN really quick after I clear the screen, and we're going to start up in no mount mode, and I'm simply going to use restore control file from auto backup. That's all there is to it. Isn't that amazing? So let's try mounting the database, and I'll issue or alter database open. And it's telling us here, as we saw in the previous nugget, we have to use reset logs for database open. So let me do alter database open, reset logs. And now it's telling us that file 1 was not restored from a sufficiently old backup. This is a clue that we need to run recovery. Now, this is something that's specific to control file restoration. You have to keep in mind that we need to do a recover database to synchronize our SCNs. And only after we've done that synchronization process can we issue alter database open reset logs. And that will finish the recovery process. Database opened and we're good. Excellent. So let me exit out of RMAN, clear the screen, and we'll come into SQL Plus again. Remember, another way to back up the control file was to do an alter database backup control file to a particular location. And the question is, well, okay, what if I'm not using auto backup, but I regularly issue this statement, so I have a binary snapshot that's fairly current? How would I do it? How would I use it? Well, what you'd do is, again, we'd hit RMAN. We would need to start up in no mount mode again from within RMAN, but our restore statement would be a little different. We would do restore control file, not from auto backup, but from, and then we would specify the path. The rest of the story is the same in terms of having to recover the database and open as a new incarnation. Those steps are the same, but I just wanted to cover that base for those of you who are not using auto backup. I don't know why you wouldn't be using it, but just in case you weren't. Now let's assume our SP file is gone. I'm actually going to delete this because I don't believe I showed you what this looked like. So I'm going to issue shutdown immediate to bring down the instance and close the database. And while that's cooking, I'm going to bring up a Windows Explorer window and we'll go search for that SP file. Product 1120 DB home, database, and there's my SP file with the Oracle SID appended. SP file orcl.ora is my name. Send that guy to the recycle bin, and if just for grins we try to do a regular startup, of course that's not going to happen at all. Do a shutdown abort to make sure that the instance is down, and let's get ourselves into RMAN. Now, of course, we haven't been connected. We're not connected to an instance, and it's telling us, RMAN's telling us right off the bat, connected to target database, which is our default Oracle SID, but it's not started. All right, and what we'll do now is startup force no mount. We need to get into no mount mode. And startup force is a way to kind of do a hard reboot of the system. It says starting Oracle instance without parameter file for retrieval of SP file. So it really doesn't know what it is. This is going to be a case where knowing the DBID is going to be a lifesaver. So I just copied that to memory to my clipboard, and I'm now going to type set DBID. Now, of course, I'm doing this in an interactive way, but your best practice is you'll want to craft RMAN scripts that contain these statements and that you already have tested them to make sure that they work. All right? That is best practice. It's fine in a lab to issue this stuff interactively and fall on our face, but that's not what we want to happen in a production environment for sure. So I'm now associating my ORCL database as the DBID. So we're focused correctly now. I'm going to issue restore SP file from auto backup. Dip into the flash recovery area. Isn't that wonderful? Sometimes, though, we have trouble in Paradise. As you see here, I received an RMAN 06172 error that says no auto backup found. Now, this is a blood-chilling error for a database administrator to see because it's telling us that we don't have something that we believe that is there. You just saw me run and see successful confirmation of that SP file auto backup a couple minutes ago. Well, here's the deal. We just have to be more explicit in terms of telling Oracle where our recovery file dest parameter is. In other words, where our flash recovery area is. So in order to fix this problem, I ran restore SP file from auto backup, and then I explicitly gave the path db recovery file dest equals EFRA, and I also was double Dutch sure that Oracle knew what we were talking about because I specified the DB name as well, which of course on my system is ORCL. With that information, Oracle was then able to hit the correct recovery destination, tap in, find the auto backup, and make that restore happen. Now that's a potentially close shave, kind of scary. So let's do a hard reboot here, a startup force, and see if we can get the instance up and the database mounted and opened. Great, everything's cool. Now that's what I wanted to see. If we come back into Windows Explorer, we see SP file ORCL is back in place. We're back in business then. Let's create one more backup type before we go into database control and see what graphical controls are available to us. I'm going to start an image-based copy of the database. Again, I'm going to tag it, and I'm going to use format to redirect it out of flash recovery. I'm going to put it out into the file system in my E-image directory. So I'll hit enter and start that job cooking. And while that's cooking, let's come over to database control and let's just see what we've got going on the availability tab in general. Now we've been over to the setup area under backup and recovery. There's recovery catalog settings, recovery settings, and backup settings. I'm going to have to quickly re-authenticate. The timeout is kind of stiff on this. The backup settings basically just allows us to configure RMAN environment, just like we do with the configure command from an RMAN command prompt. We have device, backup set, and policy. To take a look at your backups, in other words, to create a backup or to look at what's already there, we have these links under Manage. We can manage current backups, report backups. We're actually going to do RMAN reporting and monitoring in a future couple of nuggets, so I'm going to leave that alone right now, but I'm going to go into schedule backup so we can take a look and see what's going on. Now, another topic that we are going to cover later in this course that I've been intentionally not talking about now to keep things as simple and straightforward as possible is the diagnostic recovery area, the DRA. Oracle is filled with all sorts of advisors and recovery wizards. You see here that on the schedule backup page, we can go either with an Oracle suggested backup routine or we could do it ourselves. You see, this is the DRA in action. On the recovery side, it's the same deal. We can use Oracle's suggestions or we can do things manually. Because we're dealing with operating system events, file system events, you'll note that we have to authenticate as an operating system administrator as well. Now for customized backups, we can scope this, the entire database, individual table spaces, data files, archive logs, or all recovery files. Now let me grab my archive logs here just for this example. We click Schedule Customized Backup, and for archive logs it's a little bit different. When should the archive logs be deleted? You'll remember the delete input. That's the default here. If we leave immediately after backup, then that means that Oracle will back up those archived redo logs and then delete the ones from their source location because the assumption is they've already been successfully backed up. We'll click Next. We have optional encryption, optional maximum files per backup set. As we already know, those are simply RMAN backup statement management parameters. Our destination can either be disk or tape. Disk is the default. We have a job name here. It gives us this as a default. I'm going to call this archived. I'll just say arc_ORCL01. Job description there is fine. And it gives us what the RMAN statement is that's going to happen. Backup device, type disk, tag, and then we can provide a tag if we want to, archive log all. That's really the most basic way to do the RMAN. Backup, archive log all, delete input. All right? Simple as that. And there's also an edit RMAN script button that gives us a separate window, and we can click submit job to actually put the job into action. You can view the status of the job by clicking on the view job button, which I'll do right now. And it just lets us know what step we're on, elapsed time, so on. We can customize that run if we want to. We can also stop or suspend the job, as the case may be. Now, as far as image copy backups are concerned, let's go back to the schedule backup page. If we wanted to do, remember a few minutes ago I did an image copy backup to my E drive using RMAN. We can do the same thing here. I'm going to leave whole database as my backup scope, and we'll step into the wizard. And we're asked, first of all, is this going to be a full backup, or is it going to be a level 0, level 1 deal? Is it going to be hot or cold? You see, we know these options behind the scene, and for your exam you need to know those options, but it's cool that we're able to translate those RMAN commands and parameters to a more friendly setting, and we understand what's up. Are we going to do a plus archive log or not? Are we going to do a delete input? Maximum files per set? How big you want each set to be. Where's our target? Gives us a name. And also, besides giving us our disk target, it tells us the default backup location, which we can override with a click of the button. We can customize the parallelism, the backup location, tape settings. If we're using a media manager, head on over to backup set, go on over to policy. We can do retention policy. Click OK. Click next. Again, name, schedule for the future or now, and then it gives us our results. Now let's edit this RMAN script and see what's going on. It looks like it's kind of verbose when you first see it. It's giving us the compression algorithm, officially allocating the two channels to denote our parallelism, explicitly telling us we're doing a compressed backup set, and we can actually, as you probably know, I didn't specify an image copy here, so I can just customize this. Backup is copy, database and archive log, format equals E backup 1%U, and I can do the same thing here. Format equals E backup 1%U, and we'll go ahead and submit the job and click OK. So far so good, you with me? Now that we've handled backups to a deeper degree than we did earlier with RMAN, and we have some bases on which to recover from, let's run through some drills on recovering from various failures. Let's take a look at failure from a critical data file like system. So we're going to simulate a crash by deleting the system data file. We know that critical files are those that are contained within the undo or system table spaces. So I need to bring down the instance. Let me do a shutdown immediate. And again, while that shutdown's cooking, let me find the location of my system table space data files, which are by default under Aura Data and then your Oracle SID, system01.dbf. That is going to go away now. And now if we try to start up, of course we see a problem happening. Of course, the great beauty of this system with RMAN and the use of the flash recovery area is that this isn't as big of a deal as we might think, as long as we have a recent backup of our system data files. What we'll do is, since we're already in mount mode, you see here we were able to get the database mounted, we just weren't able to open it. We can issue restore table space system, boom, and into the flash recovery area RMAN goes, finds the appropriate backup piece, and it's going to restore that data file for us. Alright, so the restoration is complete. We now have to do recovery, not on the entire database now, but just on the appropriate table space. So we'll do recover table space system. Didn't take long because this isn't a very active database. And then finally, alter database open. We will not need to reset SCNs. We don't need to do a reset logs here for a critical file replacement. Alright, so that's that. And if we come back to Windows Explorer, we should see, sure enough, the system data file back in place. Everything's all hunky-dory. Now, the problem with that was the fact that the database was down, wasn't it? Because it can't stay up with the loss of a critical file. So we have users not able to access your production database. Now, if we've lost a non-critical data file, like on my system, it would be the user's data file, or it would be the example one that corresponds with the sample schemas that Oracle gives us, we can keep the database hot and online in that case. Now, how do you know what data file is what? Of course, that's the file ID, and we know that from within RMAN we can do a report schema to get a run of all of our files as well as their ID numbers. So if, for instance, we nuked the user's data file and tried to start up the database, we'd get an Aura 01110 error, and actually it would be an Aura 01157 error that it can't find that file. So how do we fix that? Well, we're going to take the file offline. Remember, the rest of the database is up and available for use. And how do we do that from within RMAN? This is a good tip for you. You can issue SQL statements within an RMAN environment, whether we're at an interactive prompt like we are now, or if we're in a run block or a script file. You just use the SQL keyword and place your SQL statement in single quotes. So we'd then issue alter database, data file. If it was users, it would be file ID 4, offline. Press enter, and then RMAN would issue that statement, and we're cool. Now, if you did happen to try to start up the system and you got into mount mode and then errored out, then you'd have to issue an alter database open statement. Now, my database is already open, so I don't need to do that, but that's an optional step for some of you that you'll have to take. Now, to do an online data file restoration and recovery in a non-critical environment, we'll just simply specify restore data file, and it is a little confusing because 4 and 5 are so close to each other. 4 is the file ID, 5 is the size of the file, so I need to specify 4 here, and then let RMAN and the magic of the flash recovery area bring back that file. And of course, you know the next step, right? Recover data file 4, and finally we'll issue the SQL statement, SQL alter database data file 4 online, and we're back in business. Now let's turn our attention to incomplete recovery, specifically point-in-time recovery from the perspective of RMAN. This is frankly easier done in the Enterprise Manager than from the command prompt, but I want to get you started with using point-in-time recovery from the command prompt environment. Best done within a run block, and the way this script is going to run, it's going to do a startup mount, so we're in the correct mount mode, and we're going to do a point-in-time restore to about 20 minutes ago. You see I've temporarily turned on the clock feature in Windows so we can see what's going on, and we're going to assume here to do a point-in-time restore of the entire database, but you can also do table space point-in-time restore. We're going to cover that in a separate nugget entirely in a little while, so we're just dealing with the database at this point, and I find the set statement works particularly well here, where we specify the point-in-time destination with set until time equals, and there's different ways to go here. Recommend you use the toDate function, to_date, to make sure that the value we're passing in here is interpreted correctly. I'm going to use 24-hour time here. Of course, that's the default. And I'm going to use European dates. I'm just a fan of putting the date before the month, but your mileage may vary. A nice thing about the toDate function is that we can customize things like that. So for instance, today is April 7th, 2012. I will say 07-04-12, and the time in 24-hour time would be 20:40. That's 8:40 p.m., about 20 minutes ago. Close that with a single tick, comma, and then I'm going to use the pattern that I want Oracle to understand. DDMM-YY, HH24:MI:SS, single tick. Pretty complicated syntax here, isn't it? Restore database, recover database, and then, of course, alter database, open with reset logs. That is the end script there for point-in-time recovery, complete database point-in-time recovery. Now, some other things we can do, as you know, you can restore the database until a particular time. So, for instance, instead of using the set until time command, we could just issue, let me do a Control-C and get back into RMAN. As long as we were in mount mode, we could say restore database until time and then pass in the time value. We could also do until SCN 1, 2, 3, 4, 5, whatever that particular SCN is, as long as we have used logminer or some other utility to get an SCN value. If we do that, of course, we would have our restore statement and then our recover database until SCN blah, blah, blah. And of course, there's the cancel option as well. Now, in Oracle Enterprise Manager, it's a little bit more straightforward to do that. Let me authenticate, and I'll take you in. So on the availability page, we can come down under Manage to perform recovery, and we can choose our scope. Remember, I told you that Oracle advisors work on the recovery side as well as the backup side. We'll talk about that and learn about that later in the course. But for your recovery scope, we can use basically the same options we had for backup. It gets even more granular though. We can recover individual tables or even transactions, if you can believe it. Now, to do tables and transactions involves yet another Oracle technology and yet another technology and skill set that we'll learn in this course a little bit later. Yes, this course is very wide and deep in case you haven't figured that out already. Flashback technology is a really quick way, I guess that's why Oracle calls it flashback, to bring back schema objects like tables and even down to the atomic transaction level. Very cool. But for our purposes, we may be interested in doing a whole database or data file point-in-time recovery. And our operation types are to recover to the current time, that would be a current restore, or a previous point in time, that is the point-in-time restore. So if we click recover to continue, it tells us here that the database is currently in open state and we are in archive log mode. If we're going to restore the whole database, we've got to bring the database down and up in the mount mode. Well, of course, we know that that's true. Please wait for this operation to complete and click refresh. Now, if we were restoring a non-critical data file, we wouldn't want to choose that option, of course. Some of the options we see are going to be specific to specific situations. Let me authenticate with my host credentials and continue. Okay, and then we'll continue. You notice we could try a startup or we could perform recovery. This is whole database recovery. And we're asked here, are we going to do current time or prior point in time? Of course, we're going to choose prior point in time. And note we can use the really friendly date and time pickers. A little bit clunky. The web programming in this isn't the greatest, quite honestly. But we can at least use these controls to make it a little bit more user-friendly instead of having to understand complicated NLS date time codes. If we wanted to do point in time based on a restore point, SCN, or log sequence number, we could do that as well. Let's click next. We're asked if we want to choose the default location or an alternate location. That would be useful if we were doing a trial restore, of course. Let's hit edit RMAN script to see what's going on. Restore database until time. So it's using the compact syntax here. And it's basically using the same NLS identifiers and the toDate function that I was going to use before on the RMAN command line. And there it goes. So we're performing whole database recovery and we're basically setting the entire database back to the state it was in at 8:40 p.m. earlier tonight. At the end of the process, we see all of the output here so we can know exactly what's going on, and it tells us you can continue to open the database using the reset logs option, which I'm going to choose here because we want the database to be active and usable. And while that's cooking, I'm going to set the stage for our final bit in the demo, and that is using image file copies and fast switching them for fast recovery. You know how to incrementally update them. That two-line script I gave you earlier is the way to do that. But I'm going to end this, let me exit out of RMAN, by running a fast image copy backup, and then we're going to learn how to switch to it in a pinch if something happens. And as long as it's a non-critical file, we can do this with the database open. Let's jump into RMAN, and let's do a report schema to get our file numbers. Let's again work with the user's table space. Actually, let's do the example table space this time, file ID 5. And we can do a backup as copy data file 5, and I'm going to format this and put it in my backup 2 directory, and I'm going to call this example df_df.dbf. And as you know, this is going to create a bit-for-bit image copy of that data file, and it's going to put it on my E drive in the backup 2 folder. Now, the idea with this is we can incrementally update this file daily or every few hours or whatever you want to do to keep it up to date, and we can switch to it very, very efficiently in the case that we have a problem with data file 5 on our live database. Now, how does that work? Well, a lot of it's going to look like it did a little while ago, actually, when we did data file level restorations and recoveries. Let me come out to my host prompt, clear the screen. I just want to make sure that the screen is as clear as possible for this stuff. And from within RMAN, we'll issue the SQL statement, alter database, data file 5. Actually, was it data file 5? Let me do a report schema one more time here. The example file is 5, yes. So we're going to do SQL, alter database, data file 5, offline. So we're going to take just the data file offline. We're now going to use the switch statement, switch data file 5 to copy, and then the path of that copy is e backup to. I better quickly check just to make sure I know the file name here. In Windows Explorer, dip into e backup to exampledf.dbf. Things are never quite as easy as they appear. I've generated a couple common errors here so we can get used to this happening and get used to seeing these error message stacks, because unless you have all of these procedures canned in RMAN scripts, you're going to come across this kind of stuff. Now, first of all, some things need to be in run blocks, other things don't. You'll find as a DBA that experimentation will help you. It's your best friend. You'll see that what I've done after taking data file 5 offline on production side, I've issued switch data file 5 to copy and then pointed Oracle to where the image copy is that I want to sub in. Oracle didn't like that. Gave me a syntax error, so I threw this statement in between a run block or inside a run block. There again, we have a syntax error where instead of to copy, RMAN was expecting data file copy. So finally, I did a run block, switch data file 5 to data file copy, provided the path, and it looks like we're good. And we can prove this by running report schema one final time and verifying that our example table space, our data file 5, is now acting on that very fast image copy backup that we created earlier. Done and done. Server managed recovery with RMAN review. At this point, we have a really well-rounded understanding of Oracle backup and restore from a user managed perspective as well as using the nifty and wonderful RMAN tool. We know how to perform complete recovery of critical and non-critical data files. We know how to do point in time or incomplete recovery with RMAN, both using graphical tools in Oracle Enterprise Manager as well as SQL Plus and RMAN command line utilities. And third, this is a really neat trick. We know how to use image copies for fast recovery and how to incrementally update those files so they're always ready to go and reasonably current. In the next nugget, we're going to continue this stream. We're going to look how to duplicate databases. That can be awfully useful for testing. We'll also learn how to do trial restores, also another skill that every Oracle DBA needs to have under his or her belt. I hope that this has been informative for you, and I'd like to thank you for viewing.